lecture number 8. Can someone revise the last lecture?
Oh, we talked about ionization energy, right? I think so.
We have discussed the mass spectrometer, lecture number 8. Yes, here we have discussed factors: nuclear distance, ionization energy, shielding effect, summary, BB amine ops. We have discussed spin pair repulsion. Now we are discussing magical graph. Now can anyone define the first, what is the definition of first ionization energy?
So it is the amount of energy required to remove an electron from gaseous plus one ion.
Yes, can you repeat? This definition is for 3 marks.
So it is the amount of energy required to remove an electron from gaseous plus one ion.
No, this is for 3 marks. It is the amount of energy required to remove one electron from gaseous atom to form gaseous plus one ion. Can you repeat this definition again?
It is the amount of energy required to remove an electron from gaseous atom to form a gaseous ion.
To form gaseous ion. Very good. So can anyone tell me the factors on which can anyone tell me the factors on which ionization energy depends?
The distance from the shell. Sorry, distance from the nucleus.
Yes, 4 factors. Yes, can anyone tell me the factors?
So nuclear charge, nuclear distance, shielding effect.
Nuclear charge. So these are the 4 factors, right? So can anyone tell me the relationship between nuclear charge and ionization energy?
Yes, sir. The higher the charge, the greater the ionization energy.
It's a direct relationship.
Direct relationship. As the number of proton increases, nuclear attraction increases, shielding remains same, ionization energy increases. More energy is required to overcome this attraction to remove the electron. Yes. Anyone tell me the relationship between ionization energy and nuclear distance? Yes.
Inverse.
Inverse, right?
Inverse relationship. So inverse relationship means, can anyone elaborate?
Like as the
greater-
distance increases.
Down the group, this reason is for 3 marks. Yes, can anyone explain?
So like down the group, the shell and the shielding increases and the nuclear attraction decreases, right?
Down the group, nuclear size increases. No need to give the nuclear charge, right?
Okay.
Down the group, size increases. Shell increases, shielding increases, nuclear attraction decreases, less energy is required to remove the electron.
Yeah.
Okay, next. What is BB aminops? Yes, what is BB aminops?
Like you want us to like tell about like the
What is B?
elements or
Can you hear me? What is BB aminops?
was it like beryllium and then boron, and I
Exactly.
think it was aluminum,
So can you
magnesium,
tell me the relationship?
sorry?
What is the relationship between beryllium and boron? Which one has more ionization energy?
Boron, right?
Yes, which one has more ionization energy?
Wait, sorry. Beryllium has more ionization energy than boron.
Beryllium has more ionization energy than boron. Exactly, your answer is correct. But why?
A second, sir. Let me look at the periodic table. Um, beryllium and boron.
Less inner electrons, maybe.
No, the reason is that when you write the electronic configuration of beryllium, so configuration ends with 2s. When you write the electronic configuration of boron, it ends with 2p1. So 2p is further away from the nucleus than 2s. So here we have 4 inner electrons. Here we have 2 inner electrons. So more inner electrons, more shielding, less ionization energy. Beta, are you getting my point or not?
Yes, sir, I got it.
Okay, next. Now compare ionization energy of aluminum and magnesium. Yes, what is the relationship between? Yes, anyone compare the ionization energy of magnesium and aluminum?
Magnesium has more, right, or higher, requires more ionization energy.
Yes, Q. Can you tell me why?
Because first of all, aluminum has more inner electrons, and as a result, uh, the shielding effect is comparatively higher than
Exactly.
magnesium's.
Very good. Very good. Very good. Now, can you compare ionization energy of nitrogen and oxygen?
Yeah, sir, it's sort of the same thing that's complied again. So, nitrogen has higher or more ionization energy than oxygen, and it's because of the same reason in this
No, it's
case.
not the same reason. It's
Oh,
not
wait.
the same reason.
Yeah, they have the same amount of inner electrons, so the shielding effect will be the same.
No, no, no,
But
no, 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 no. Now look at it has 3 electrons. It has 4 electrons. So it has 3 unpaired, and oxygen has 1 paired and 2 unpaired. So paired electron repel each other. So quite easy to remove 1 electron from oxygen because they are paired. Paired electron repel. This phenomena is called spin pair repulsion. Are you getting my
uh,
point or not?
yes, I am, sir.
Now explain this for sulfur and phosphorus.
So it's the same thing that's what do you call applied here with oxygen. So they both have the same number of inner electrons, But sulfur has one more electron, so it has two paired electrons, right? Which means that they repel each other. So it's easier to remove one electron from sulfur than phosphorus.
Yes, very good, very, very good. Because sulfur has more inner electron, you can see that here we have more electrons, here we have less inner electron, right? But the main factor is spin pair repulsion, right? You can see that both have same inner electron, 6, 7, 8, 9, 11, 12. It has 12 electrons. So they have same inner electrons. So the factor is spin pair repulsion because sulfur has paired electron. Paired electron repel each other. Paired electron repel each other. So less energy is required. Less energy is required. Now magical graph. Now magical graph. Consider this graph. Here you have number of electron removed. On x-axis you have ionization energy or log ionization energy or ln ionization energy. Let's suppose this graph is uh, let's suppose uh, this graph belongs to sodium. So you know that sodium has 281. Sodium has 281 electrons, 11 electrons. So can anyone tell me how many valence electron in sodium?
One.
One. So here we have one electron for sodium. Now you can see that the electrons, right? Here we have two electrons, then 8 electrons, then 1 electrons. In the nucleus, you have 11 proton. Now, when you remove one electron, when you remove one electron, you can see that shell is changed. When you remove one electron, shell is changed. Now, can you tell me ionization energy increases or decreases? Yes, beta, when you remove one electron, one valence electron, shell is changed. Now, can anyone tell me second ionization energy is greater than first one or lesser than first one?
Is it going to be less?
Why less? You know that
Because
shell is decreased. Now, valence electron is near the nucleus. More nuclear attraction,
Increase,
more
right?
energy is required.
but sir, what about the shielding effect? The inner electron hasn't that decreased?
Now, yes, shielding also decreases because shell is changed. Now you have only two inner electrons. In this case, you have 10 inner electrons. So as shell decreases, shielding decreases, ionization energy increases. Now you observe drastic change. Now you observe drastic change. Why this drastic change? Drastic increase of ionization energy. Because shell is changed. Now remove another electron. Now remove another electron. Now remove another electron. Now remove another electron. Here we have electron 11, proton 11. Here we have electron 10, proton 11. Here we have electron 8, proton 11. Sorry, proton 9 electron, because one electron is removed. Now can you tell me, after removing second electron, ionization energy increases or decreases? Yes, beta. If you remove another electron, ionization increases or decreases? Beta, tell me, when you remove further electron, ionization energy increases, decreases?
Uh, I'm not sure, sir. Will it like decrease?
Now look at Mohammed. As you remove the electron decreases, number of proton remains same.
Yeah,
If number of proton is remain same, it means nuclear attraction increases.
yeah.
Whenever nuclear attraction increases, ionization
Okay.
energy also increases.
Okay, so
So
it'll increase.
second, exactly. Second increases, third increases, fourth, fifth increases, sixth increases, seventh increases, eighth increases. So all eight increases. All eight increases. All eight increases. Then after removing all six electron, again shell is changed. Now you observe again a drastic change. Again you observe drastic change. Again you observe drastic change. Why? Because shell is again changed. Because shell is again changed. Drastic increase of ionized energy because shell is also changed. Now write the note for it. Last time graph is plotted between ionization energy. Okay. So always remember, this indicates valence electron. Valence electron. This indicates group number. This indicates group number. So valence electron means group number. Valence electron means group number. Similarly, you can find number of shell. Number of shell is equal to number of big jump plus 1. Now, can you tell me how many big jump in sodium?
Two.
Yes, 2. So 2 plus 1 is 3. So third period, now you can open periodic table and you can see sodium belong to period 3 and the group number is 1. Now check, am I right? Yes, can anyone check?
Yes, sir.
Okay. Now graph for calcium. Ionization energy graph for calcium. Calcium has 20 electron. 2, 8, 8, 2. This is calcium graph. So you know that calcium has 2 valence electron. So initially you have 2 electrons. Initially you have 2 electrons. Then 8 electrons are removed. Then again 8 electrons. Then 2 electrons. Now, can anyone tell me the group number of calcium from the graph? Yes. Can anyone tell me 2? Why 2?
Because two valence electrons.
Because 2 valence electron. Very good. Now tell me the period or shell number. Yes.
Four.
So you have 3 big jumps plus 1, 4. Now you can check the group number for calcium and period from the periodic table. Either I am right or wrong. Group
Yes,
number
you're
Yes.
right.
2. Very good. So ionization energy tell us about the group number and period number. Now next is fluorine. Fluorine. Fluorine is 2, 7. Fluorine is 2, 7. Now look at the graph for fluorine. For fluorine, in the first cell you have 2 electrons. Mohammed.
Yes, sir.
Okay. Okay. Mohammed, Isa, and Zaina. Please respond, right?
Yeah, sure.
So fluorine has 2 electrons and then 7 electrons, right? So first I remove 2 electrons. Am I right?
No.
Yes.
Am I right? First we remove 2 electrons or 7 electrons?
Wi-Fi
No,
7.
7.
7 electrons. So this is wrong
Don't we have to add an electron, sir?
because we remove the electron from the valence shell and in the atom is fluorine. So when you remove the electron, first 7 electrons are removed because fluorine has 7 valence electron. Then you have observed big jump and then 2. Now tell me the group number
7.
and period. Yes, group number is 17, not 7, 17. And what about the period number?
Second period.
1 big jump plus 1 second. Now look at fluorine. Am I right?
Wait, sir, how did you get like the group number 17
Because,
on the graph?
yes, because you have 7 valence electron.
Yeah.
Okay,
Uh-huh.
7 or 17, both are same.
All right.
Because in the periodic table you have 10 transition metals. So after one, group 2, you have group 13. After 2, you have group 13. Because 10 rows, 10 columns, 10 groups are for transition metals. All of you getting my point or not?
Yes, sir.
Mohammed, Zaina.
Yes, sir, I got your point.
Okay. Zaina, are you in the class? Zaina is not in the class. Okay. Now fluorine. This is fluorine, gaseous. This convert into fluorine positive gaseous. Then we convert +2 gaseous. Then we have F+3 gaseous. F4 gaseous. Then F5 plus gaseous. Then F+6 gaseous. F7 plus gaseous. F+8 gaseous. Then F-9 gaseous. So can anyone tell me how many electrons in fluorine?
9.
9. So fluorine has 9 electrons, so 9 ionization energy for fluorine. Fluorine has 9 electrons. Fluorine has 9 electrons. So 9 ionization energies for fluorine.
So why did you write F minus 9 after F plus 8?
Sorry, it's plus, it's plus.
Oh,
I'm sorry,
okay.
it's plus. So
Okay.
this is first ionization energy. This is second ionization energy. This is third. This is fourth. This is fifth. This is sixth. This is seven. This is eight. And this is nine. First, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. So fluorine has 9 electrons. So 9 ionization energy for fluorine. Can anyone tell me where you observe big jump? In first ionization energy, in second ionization energy, or third ionization energy? Where you observe big jump?
So 7th.
7. Very good. So after 7th ionization energy, you observe big jump. Now, write another question. Identify group number. Identify group number. This is first ionization energy. Second ionization energy. Third ionization energy. Fourth ionization energy. Fifth ionization energy. Sixth ionization energy. So first ionization energy is 100. Second ionization energy is 120. Third is 9,000. Fourth is 9,100. Then 9,200. Then 9,350. 90,350. 90,200. 90,100. Then 90,000. Yes, can anyone identify the group number? Yes.
Was it group 4?
Why group 4?
Because the first 2 electrons, sorry, yeah, it's going to be, so there's 6 electrons total removed, right? 6 stages.
No, no,
And
no,
if
no,
you,
no, 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 no.
um,
Can you tell me where you observe big jump?
oh, 120 to 90,000.
120 to 90,000. So it means valence electron is second.
Oh, so group 2.
So in the valence shell you have 2 electron,
Okay, sir, got it.
because after second energy you observe big jump. Zaina, are you in the class?
Yes, sir. My internet
Okay.
is bad right now.
Okay. So can you Zaina, can you tell me why the group number is second?
I thought it was gonna be third as well because of the like number of jumps. Like, and then you
Now,
add one to
now listen, Zaina. Here we have 100. Here we have 120, right? So after 120, you observe a big jump.
yes.
It means shell is changed. After second removal of electron, you have big jump. So it means in the valence shell, you have 2 electrons. That's why group number is 2. Are you
Okay.
getting my point?
Yes. I think
Okay,
I'm
can you,
getting it now.
okay, Alhamdulillah, can you tell me again why it has sec, why it has group number 2?
Because it suggests that it has 2 valence electrons. Because after the second, you observe a big change in the
Exactly.
energy
So
ionization.
exactly. Very good, very good. Because big jump is after second ionization energy. Now next question. All questions are from past paper. Identify.
Wait, sir. How could we tell the period, like the period number based on the first question?
No, no,
Like,
no. We cannot say. We cannot predict here. We
we
cannot.
can't.
We are no. No one can predict the period number in this question.
Okay,
In
why is
such in
that?
such in such question, period number is always given
Okay.
in such question, right?
All right. Okay.
Through the graph you can predict. Now identify A in MCLA. M is metal. M is any metal. Now again period is given. Now again this table is given. First ionization energy is given. Second is also given. Third, fourth, fifth, sixth. So this is 200, 210, 230, then 80,100, then 80,200, then 80,300. Now can anyone tell me the value of A, small a? Yes, can anyone tell me the value of small a?
So
With
the
reason.
leap. So the leap is from 230 to 80,000, right? So that's going to be the third group,
Third
and
group, very good.
if
Very
it's
good, very good.
ML,
So it means valence electrons are 3. So it gives 3 electron. So it means it is MCl3. Your answer is correct. Are you getting my point?
no, no, I don't understand the reasoning, sir.
Now listen again.
Okay.
It means you have 3 electrons because you observe big jump after third ionization energy. You observe big jump after third ionization energy. It means M has 3 valence electron. So it means M has the capability to give 3 electron. So when M gives 3 electrons, so M become plus 3. You know that chlorine is -1. So formula would be MCl3. Mohammed, are you getting my point or not?
Yeah, I am. So, sir, in this case, is M magnesium or is it any like variable?
No, it's any variable, right? It's
Ah,
metal.
okay, okay.
M means any metal.
Okay, I thought M is magnesium. All right, sir. I
No,
get
no,
it now.
no. Now the reason is that, now write the answer. Because big jump is after third ionization energy. So 3 valence electron belong to group 13 with +3 charge. Now next question. Identify M identify identify group number of M and find the value of A and B. And find the value of A and B. Question is M, B, X, A. This table is for X. Now this table belongs to X. This table belongs to X. Seventh ionization energy is also given, which is 80,600.
Okay, so now we know that the leap occurs uh on the fifth ionization energy, right? So 250 to 80,300.
Okay.
And if we take that into account, then A's value should be 5 electrons, right? Because it donates 5 electrons.
Okay. Very good.
And
Very, very good.
if A is 5 electrons, uh, M is a metal. That's excellent.
Yes, Zania. Yes, what is your opinion? What is the value of A and B?
I'm not really sure.
Okay. And you? Yes, Umar. Any idea?
Sir, are you asking me?
Yes, 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 you.
Sir, I'm not Omar.
What's your name?
Isa.
Isa, Isa, I'm sorry. Isa.
Yes. Sir, I
Yes.
think B should be 5.
B should be 5.
Yeah, I think.
Okay. Now listen. Group number is 15. Can anyone tell me group 15 elements give 5 electron or accept 3 electrons?
Except 3 electrons, generally speaking.
Okay. If they accept 3 electrons, so charge is 3 minus 3, not plus 5. Group number is 15 of X. So it requires three electrons. So it requires three electrons. So M is plus 3, X is minus 3.
Oh, okay, I see your point.
So M 3, X 3, 3 cancel. MX is the answer.
All right, sir.
Now another question. A graph is given. On y-axis you have ionization energy, and on x-axis you have successive proton number. Here you have A, here you have B, this is A, this is B, this is C. This is big jump. Identify A, B, and C. Group number, group number. Yes. Can anyone try this question? You have to try. Yes. What is the identity of A, B, and C? Periodic table is given. Now, can anyone try?
Okay, so A is
Yes.
uh A is so it has one electron, right? So it's
Mhm.
going to be in group one.
A is in group 1.
Yes, I believe so.
Why?
Because A has one electron. Like if you look at the ionization energy in the earlier stages, it only has one.
No, no,
Oh,
no, 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 no. Initial graph is missing.
yeah.
Initial points are not given.
So there's one leap and then big jump down. Successive proton number.
Now look at, leave it. Now I am trying to give more easiest question, right? This is A, this is B. Now you observe big jump. Now tell me,
So it's in group two then.
no,
1 plus 1, isn't that the group's formula? Like they're
no,
closely.
initial points are not given. Initial points are not given. Few points are missing.
So we know that there's one massive leap, right?
Yes.
Okay, so we know that
Uh,
there's one leap.
before the big jump, few electrons are missing. After the big jump, few electrons are missing. This is big jump.
Okay, well we know that the ionization energy starts at A, right? Or is it before A? Can be.
So always remember, big jump, we observe big jump when shell is changed. Shell is changed after the group 18. So this is group 18. Group 18 means group 0. This is group 17. And this one is group 1.
Wait, could you repeat that, sir?
Yes, A is group 17. B is group 0 or group 18. And C is group 1. Why? Because shell is changed after group 18. So shell is changed after group 18. Any question?
No, sir, I got it.
No, sir.
Okay. Next question. 9701, variant 12, May, June. Question number 12. Two 2005, summer. Question number 12. Hmm. Sorry. Question number 12. Sorry. Yes, question number 12. Now solve this question. Yes, which one is correct?
Sir, A?
A is correct. Okay. Why A is correct?
Because argon is in group 18, and then potassium in group 1 and calcium in group 2. So after group 18, the shells increase, right?
Okay.
I think.
Okay. Now listen. You know that argon is 18. So 2, 8, 8, 8. Potassium 19, 2, 8, 8, 1. Plus mean remove this electron. Now calcium 2 plus 2, 8, 8, 2. Plus 1 means, plus 2 means remove 2 electrons. So electronic configuration is same. But the only difference is the charge. Argon doesn't have any charge. Potassium has plus 1 charge. Calcium has plus 2 charge. So as the positive charge increases, size decreases, ionization energy increases. Are you getting my point or not?
Yes, sir.
Yes. Any question?
Nope.
Hamza? Hamza,
Nope,
do you have
sir.
any question?
Nope. I've got no
Okay.
questions.
Okay. बेटा आपको क्या नाम है आपका जानिए?
No, sir. Okay.
Do you have any question?
No.
Now listen. Argon has 0 charge. Argon has 0 charge. Potassium has plus 1 charge. Calcium has 2 plus charge. Shell remains same, but positive charge increases. As the positive charge increases, size decreases. As size decreases, ionization energy increases. Are you getting my point or not, Peter? As positive charge increases, as positive charge increases, size decreases. Size decreases, ionization energy increases. So which one has high ionization energy? Argon, potassium or calcium?
Calcium.
Calcium. So calcium plus 2 is greater than, yes, then
Potassium plus
very good, then
argon.
argon, and then argon. Now next question. Question number 5. Question number 5. Yes. Now try to solve this question.
So, sir, if they say dicarbonate,
Yes,
oh,
this is
how
carbon.
electrons are present in the molecule?
Now, can you tell me the group number of carbon?
Carbons in group 1, 2, 3, 4, 5,
14,
14.
14.
Yeah.
So it has 4 electrons. And oxygen? Six.
oxygen group 16.
SIP 16. So it must have
6 electrons in its outer shell.
exactly. Now this is CC. So it is also C. This is C2O.
Yeah.
Can you tell me? Can you tell me the lone pair?
So 3.
Three. Correct answer. Lone pair three. Three or two?
Two, sir. It's two, right? Because it's 1, 1, 1, 1. So that's 2 pairs of lone electrons.
What about this carbon?
Which one, sir?
This one.
Oh yeah, that's three then.
So three. This is one, two, three. Now 9701, variant 11, variant 12, October, November 2008, question number 3. Yes, 2008. Winter, question number 3. Sorry, question number 3. Yes. Anyone? Yes, anyone? In which pair do both amino both atoms have have one electron only in an s orbital in their ground state? Now listen. First, write the electronic configuration of calcium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So calcium has 2 electron. Copper, you know that 4s2. Are you getting my point or not?
Yeah.
electronic configuration of calcium is 4s2. So in which pair do both atoms have one electron only in an s orbital? But here you have 4s2. So this answer is correct or wrong? Can you tell me A is correct option or wrong option?
Wrong.
Why wrong? Because it has 2 electron in S. Now next is copper and beryllium. So copper is exception. 1s2, 2s2, 2p6. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s1, 3d10, 3d10, 3d10. This is copper. Now can you tell me how many electrons in valence orbital? In which pair do both atoms have one electron only in its s orbital? This option is correct or wrong?
Wrong, sir.
Wrong. Because this option is copper is correct because it has one electron in s orbital. Now look at the scandium. Scandium I think 21. So 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. But this one is wrong. So both in first option have 4s2, 4s2. So this is wrong. Copper is 4s1 correct. Now beryllium. Beryllium is I think 4. 1s2, 2s2. So this is 2s2. So this is also wrong. We need one electron in both cases. Now next is hydrogen. Hydrogen is 1s1. So it is 1s1. But helium is 1s2. So again, this is wrong. Now last is lithium. Lithium is 3. 1s2, 2s1. This is s1. Now chromium is 29. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. So it has 4s1. So which one is correct? Beta,
D.
which option is correct?
Option D.
Option D is correct. Because both lithium and chromium Hamza, are you getting my point or not?
Yes, I am, sir.
Okay. So both have one electron. So next, next question. We have two isotopes of sulfur, sulfur 32 and sulfur 34. AR is 32.09. Find percentage abundance. Sulfur 32, percentage abundance, sulfur 34. Yes, sulfur 32, sulfur 34, AR is given 32.09, percentage abundance of 32 and percentage abundance of sulfur are required. Yes, can you tell me how can we find this one? Yes, can even tell me how to solve this question? Sulfur has 32, sulfur 34, total AR is 32.09, percentage abundance of sulfur 32 and percentage abundance of sulfur 34 are required. Now use this formula. AR is equal to X1 Y1 plus X2 Y2 divided by 100. So 32.09 is equal to 32 times Y1 plus 34 100 minus X 32 is X, right? You have to find percentage abundance of both. This is 100 minus Y. Divided by 100. Divided by 100. So when you multiply 32.09 by 100, the answer is 3209. 32 times Y1 plus 3400 minus 34Y. So 3209 is equal to minus 2Y plus 3400. So minus 2Y is equal to 3209 minus 3400. So Y is equal to, can anyone tell me the answer? Can anyone tell me the answer?
95.5.
Sorry?
95.5.
95.5. 95.5% is Y, and 100 minus Y is equal to 100 minus 95.5. Just tell me the answer.
So it's 4.5. Wait.
4.5%. So percentage of sulfur 32 is 95.5%. Percentage of sulfur 34 is equal to 4.5%. Okay, any question?
Sir, why did you take y1 as y, but y2 as 100 minus y?
Because you have only two. If y is, let's suppose y is y1, then the second one is 100 minus y, because sum of the percentages equal to 100.
Yes.
On the y-axis, you have percentages. So y1 plus y2 is equal to 100.
Okay, sir. I got it.
Any question? So inshallah, from tomorrow, inshallah, we will start past paper, right? Tomorrow
Yes,
we
sir.
will start past tomorrow, inshallah, we will start past paper of first chapter. Tomorrow
Sir?
we have, yes,
How did you know that 32S has 95.5% and 34S has 4.5?
because y, we assume y1 for 32. You can
Okay.
see that y1 is for 32.
Yes, yes.
That's why y is equal to 95.5 and silver 32 is 95.5. Okay, any question?
No, sir. I'm just fine.
Okay, okay. So inshallah, tomorrow we will take another class, right? And we will start past paper. Do you have any questions, Zaina, Hamza, Isa?
No, sir. No questions.
No questions, Zaina, no question?
No, sir.
Okay. Take care, Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.
Yes, sir.
Allah Hafiz.